Okay, use these videos as help for your practice problems as you need. And as always, if you have questions, please send me an email. Okay, so here we go. Number one, this is from lesson one, by the way. Filling out your table here, the product, we'd have 49, 96, and 400. Now find a pair of numbers that have a sum of 50 and will produce the largest possible product. Well, I noticed that like right here with these two numbers being a little bit closer to each other, I'm getting a much bigger product. So I'm going to try a few more. Maybe we'll do like 20 and 30. Still have a sum of 50. Now I have a product of 600. So I'm going to keep getting closer together. I might as well just try it when they're the same. And that'll be 625. And I'll notice that if I keep going with pairs and try that again, now I'm getting smaller products. So 25 and 25 is going to give me that largest product of 625. And my explanation came along with it. Okay, in problem number two, number one, here's what my table ends up looking like. And what did I notice? Well, I noticed that when my length and perimeter, or length and width, were the same, it did give me the greatest area, which means this shape right here would be a square. So the square with that same perimeter of 20 will have the greatest area. Number two, I'm going to make a prediction and say that if my length is 5.25, so it's going to go somewhere right here, I'm going to predict that my area is going to be less than 25. If I do the math, we will find out that it is less, but that's my prediction based on what I see on the table. And number three, you can see my points I plotted there. Do they change in a linear way? Nope, definitely not. Not a straight line. Do they change in an exponential way? Nope. We've just been working exponential. Remember, those will look like this with exponential growth, or like this with exponential decay. And we're not seeing that. We're seeing that it goes up and then down. On this one, the length between, or the relationship between the side lengths is linear because we're always adding the same number. Here we're adding 2, adding 2, adding 2. Here we're adding 4 to each one as you go down. The change in the area, though, is not linear or exponential because we're not adding the same number as we go down. That is not consistent. And we're not multiplying by the same number as we go down the table because that is not consistent either. So it's neither linear nor exponential. Number 4 in lesson 1, describing the relationship. The correct answer here is going to be C. As the side length increases, as you go this way, the area does not increase or decrease by an equal amount. It is increasing for a while, and then it is decreasing for a while. But even when it is increasing or decreasing, it's not happening by an equal amount. Now on to lesson 2 problems. I showed my work on this first one. How many small squares are going to be in step 10? It is going to be 110. How I did it, I just tried to see the pattern, what was happening, and I noticed that one side was the same as my step number, the other side was one greater than my step number. I would multiply those two things together to get my number of squares, and so n plus 1 times n. If my step number is 10, plug in 10, and I got 110. All right, on to problem 2 in lesson 2. I just drew out what step 4 would look like for each of these. Step 4 would have 16 dots in pattern A and 18 dots in pattern B. And which pattern shows a quadratic relationship? And that is going to be pattern B, because in pattern B, what's happening is that we're taking the step number and squaring it and then adding on, whoops, not 4. We're adding on 2. So we see the squared part right here where we took, in this case, 4 squared, and then we're adding on 2 more right there. Same thing here, we took 3 squared, that's 9, and then added on 2 more right there. In problem 4, the ones that would have a quadratic relationship are A and C. The rest of these would all be linear relationships. And yeah, A and C are the only ones where we would have anything being squared. Do remember that n times n is the same thing as n squared.